just want to give a shout out to our sponsor, Microsoft. Without them, we wouldn't have this room, so I'm really happy that they decided to sponsor our user group this year. And with that, we'll get started. So we're going to talk about just the fundamentals of iOS development, and then getting into more of the Xamarin iOS development aspects as well. I started off these workshops as a way for people that are digging into Xamarin development to kind of rewind a little bit and actually get a good sound knowledge of the fundamentals. Because a lot of the Xamarin sessions that I was running were really at a high level and talking about how to do things in Xamarin specifically, but not really explaining a lot of what components were in each platform. So I started off my first two workshops focusing on the Android side of things, and then now I'm doing the next two will be on iOS, and then I believe after that I'll do a couple just on Xamarin Forms, which will kind of be a whole different aspect of cross-platform development. So I'll start off with the building blocks of an iOS application. When you think about running an application on your phone, all you really care about and all you see is the app that's running and kind of how the interaction that you have available to you and what you can do within the app. But what's really going on behind the scenes and how are things like that loaded in? What are the things that make up an iOS application? So first, there's the UI application object that facilitates the interaction between the system and other objects in the app. You'll notice that in iOS, a lot of the components you're working with are prefixed in some way, and UI is a common prefix that you'll see a lot. Then there's the application delegate that works with the application object to handle app initializations, state transitions, application events. And you'll see that in the code. We'll actually see what an application delegate class looks like. All right. Then there's the window. So in an application, there is one instance of a window. That's essentially the container for your application. This is where you'll see all the views rendered, and as you navigate through pages, it's always being rendered in that one window. You only have one object of that. That window is hosted in a UI screen. That actually references the physical device, the screen of the physical device. And from that, the things that you'll be able to get is like the bounds of the device. So if you're running on a device and you want to know what the width and the height is, you can be able to get that. There are other things that you can get, but that's generally what it's used for. Okay. Views. So when you're talking about a view, in other applications you may think like the whole window, but in iOS a view is really just like each individual object that you're adding to your window. So a label is a view, a text field is a view, an image is a view. Each of those things represents UI view. They all subclass from UI view in some way. So then you'll see that on the form. You can also nest views. There we go. You can nest views, so then that makes it like a view hierarchy. So if you're thinking of, you have a scroll view, that's another form of a view. To that scroll view, you'll add maybe a label, a button, then you'll add like a table view. Then that table view will host items within it. Those are nested. Those are other views as well. So it's not just like a one-to-one. It's really important to get comfortable with understanding the view hierarchy, because if you're programmatically managing views in code, you'll have to understand where you look for those views. All right, and then view controllers. This is where like kind of the logic happens for your view. It loads up the view. It manages the interactions with your underlying data. There's a lot of things that you can programmatically do from your view controller, and I'll show a little bit of that in code. But essentially, even when you create, you can create like views using multiple mechanisms, and we'll get to that in a bit. But a lot of that interaction will happen within the view controller. It's kind of that model view controller design pattern is what iOS is kind of really well known for. If you're used to WPF development, we always have used the model view model pattern. The model view control pattern is very similar in that it keeps an abstraction between the view and the data and the interaction logic that goes on. All right, so in a Xamarin iOS application, what does this look like? Where do these all fit in? So you have your main class, then that's the entry point for your application. That's where your static main is. In your main, it creates an application instance, and it names what your application delegate class is. So by default, when you create a Xamarin iOS project, it automatically creates an app delegate class that's named appdelegate.cs. And so that's what's passed here. It's just a string that references that. You can name your app delegate class whatever you want, but just make sure that you then update this name to match that, because that's what it's doing. And that's really the point of being .cs. And then your app delegate class, this is where you have a little bit more going on. You have your instance of your UI window is available here. You can see that as an override. And as you can see, the app delegate is also extending like the UI application delegate, which is really where everything happens. The most important thing in your app delegate class is your window and your override events, which handle your application lifecycle essentially. Generally, in finished launching, you'll see a lot of initialization code for your application at a global level, not at a view level. At a view level, that happens somewhere else, and we'll get to that in a bit. Here you can subscribe to system updates and essentially receiving notifications from the OS, like finished launching is a good example. And then when your app delegate completes running, what happens then is you have your UI window, which is initialized, that's attached to the screen, and your UI window will have a view controller that is the default view for your, that will load the default view for your application. You have to specify what that is. So if you do not specify a view controller and you don't have a view controller application, your application will run because it won't know what to load. We'll show how all that stuff is wired up in the IDE. All right, so application lifecycle events, and that was in the delegate class. I showed you a bit of those. You have your finished launching, your activation, your on-the-fly activation. All those things that happen, you have access to perform your own custom code in there, your own custom interaction. Just note that when you are putting code in the backgrounding events, you only have a few seconds. So don't put anything that's long running in these events. It's not a good idea. Your app will likely crash. And the will terminate is a good place to clean up resources when you know the application is going to be terminated or like closed. It can be closed unexpectedly, so you want to make sure that you make use of that to clean up any application resources that could be left open or that you want to kind of make sure that it is cleaned up. Sorry. So let's take a look at an iOS project. Well, Xamarin iOS, I guess. I shouldn't say iOS. Here. And you'll notice that, do I have my zoom on? No, I don't. Okay. So notice that there's a main class. Let me get my magnifier there. Okay, so there's that main class, which is the entry point. And the only code it has is really just initializing that UI application. And then naming my app delegate, which is great. So then I have my app delegate class. Nope. Didn't want to do that. There you go. The one great thing about your Xamarin iOS template when you are creating this is that it gives you a lot of nice comments within the app delegate class to guide you as to what those events are and how to use them and what typical things you can put in there. I don't have anything in here at all. And remember how I mentioned that you have to like specify what your view controller is and like what that default view is? I'll show you what I did instead. I actually didn't have to specify it in code because there's another way to do it. Another thing that's created when you create like a default Xamarin iOS application, just from the blank template, it creates this launch screen storyboard. And that's essentially what you use for your splash screen. So you may want to customize this, throw in your own custom image. You can get rid of that just text, which is all that is. And we'll get more into that stuff a little bit. Asset catalogs. This is generally where you will find your application icons. You may have to create your own and then add them to this, which is great. one thing that I did, which is a little bit off topic, but in order to make my life easier, there was makeappicon.com. I just went here and I uploaded a single image and it created all those the icons in the right sizes for me, and I just downloaded it and then added it to my calendar. It's taking forever to load right now because I'm on my phone, so it's not going to do it. Anyway, so makeappicon.com. And notice that your references that you have access to, obviously, the system libraries, but then you have your Xamarin iOS references as well. This is where you're going to have access to your specific iOS APIs. UIKit is a popular one. That's one you'll be seeing throughout the examples that we're doing today. UIKit, Foundation, Core Graphics are the three namespaces you'll likely be using as you're developing these apps, or your Xamarin iOS applications. Okay? The view lifecycle. So in my view controller, I only have one in this application. It extends from UI view controller. I have a ton of overrides for the view lifecycle events, but I'm not really using them, except for the view did unload and the view did load. Whenever you put in custom code in the override events in iOS, always make sure that they follow the base call. So you have that base call in there, and then you put your code after. It's generally, that's considered best practice, not to put your code in before that happens. So that's just generally the makeup of a basic app, a single view controller. And view is defined in the storyboard, and I'll get to that in a minute as well. So, what other things did I want to mention? This is a little bit off topic, but there is info view list is where you set your settings for your application. I never access them right within the info view list designer in Visual Studio, but a lot of them are available right through your project properties. So if you go to project properties and hit iOS application, you'll see them here. You have where you define your main interface. That's what I mentioned before as far as defining my group view controller. Here I just defined it as the only storyboard that I have in the application. And then it just defines, like you can define that custom artwork, launch images, and things like that here. So this is a good thing to know as far as when you're setting those, when you're creating your application package and putting things together. It's a little bit off topic from views and view controllers, but I just wanted to point that out since we are here. So view lifecycle events. Oh, I thought I already covered that. Okay. Your view did load is only called one time when your view is loaded. After that, when your application is running and your view is backgrounded, like if you're navigating and it's just the background, it will be like it will disappear, but then it will still kind of be loaded in memory. So view did load won't be hit again. So this is like a one-time setup of your view. View will appear, did appear, view will disappear, and view did disappear will generally be the ones that are called when it's backgrounded and then being restored. So you have to kind of understand that life cycle when you're thinking about saving transient data and then restoring it in the view. Okay? User interface controls, there's a ton. Oh, why did I make them each transition like that? So common controls that you'll use will be scroll view, label, button, text field, text view, image view. There's a ton more. I'm not going to get into collections like controls that hold collections as far as list views or table views because those are a separate workshop in and of itself, just the setup in those. But just for basic views, that's generally what you'll be using. And when you're designing the user interface, you have multiple options. There's the Xamarin iOS designer that's for the storyboards. I should have put storyboard designer there. The Xcode interface builder, so you actually can use the Xcode interface builder to design your views. They'll just be saved as zip files, like the XID files. Or you can just programmatically create your view in C#. Within your view controller, you can just programmatically add views and create your view out of view. It can be a little bit messy that way, but those are the options that you have. Then you want to register event handlers for views which require user interactions. So if you're adding a button, then you're probably going to want to register an event handler on that button so that you handle the tap when the user taps on the button and what that looks like. I don't like these transitions. Okay. The events on the buttons are not what you'd expect in .NET. So in .NET we have either click or tap, but in iOS it's actually touch. So you have touch down, touch up inside. So touch up inside essentially is when the user's finger is actually within the bounds of the button, if you're thinking about a button, and then touch up inside. Touch drag. So you have your drag and drop events which are available. So that would be drag inside. Drag exit, drag enter, and then you have editing events on like the text fields. So when you're thinking about how do I know when the text field is being, the user's typing in it, well, there's editing, did begin, did end, editing changed, but I generally listen for the value changed event if I want to see what's happening within the text box, essentially. So those are the different names that are not. They're not what you'd expect in Windows, but in iOS, those are it's kind of an odd naming convention. That's what they have. So designing the storyboard, the nice thing about that is the drag and drop from the toolbox right onto the storyboard. There is the problem with that, and I'll show you in a little bit, is when you're dragging those controls on as is, you're essentially placing them and then they're setting the coordinates of where they're laid out. That's not really good for a responsive design. That requires kind of setting up your view for like auto layouts and set and defining constraints. But again, that's a separate talk. That's outside of the scope of this workshop. But it's just something to know that setting up your view in iOS is not as straightforward as it looks. You can add your controls, but as soon as you get into different form factors, it's going to really screw it up until you master constraints and auto layouts. And then there's also a way to create segues, and segues are just ways of transitioning, like what happens when you click that button. You can kind of define like a transition for that. But again, that's a different scope. That's outside of the scope of this workshop. We'll do that another time. When you're designing the storyboard, you have access to properties as you would in a Windows application. You can set properties right within the properties tab. It's divided into 3 sections: widget, layout, and events. So widget is a common UI with the properties on the view. Layout kind of just has all of the properties that allow you to define how it's laid out in the storyboard. And then events, if there are any events that you can wire up on that view, you can wire them up there in that section. You can also programmatically modify these properties, the layout properties, and programmatically subscribe to events as well. Okay. One thing to know is when you are setting a name on a UI view in the storyboard, that generates this outlet code in the designer, and then that just gives you a way for your application to reference that UI view within your code, essentially within the code behind. Okay. And let's take a look at what that looks like. With some common controls on it, I have an image view which I didn't give a name. It has because I don't really care. I'm not going to reference it in the code behind, so I didn't associate a name to it. I did associate a name to a button that I added. Now, when we go into that designer, which you'll see is in this main view, it's part of the main view controller class. It's just a part of the class. You'll see that there's only a few outlets generated. One of them being my button, because I gave that a name. So then it created that outlet here. And then I am able to access that button in the code behind here. So you can see that I'm actually affecting the change on that. So obviously the designer file is something that is going to be regenerated every time changes are made, every time you save, compile. So that's not an area where you're going to end up putting in your own code. That's code that's going to always be kind of generated by the system. when you're viewing the storyboard and you're dragging it around your views and you want to see how it looks maybe on like an iPhone 6, you can just change that and it'll change the form factor that's shown in the designer. And there's a way to rotate it. Yeah. So you can see, like, even as I'm changing the way that it's rendered, it looks like it's rendering okay, but the problem is like if you actually do look at different form factors, it's not, there's times that could kind of go off the screen. So here I am in an iPhone 4, and I can already see that there could be problems just in rendering my view whenever I'm changing it from landscape to orientation. I'm amazed it actually is looking as nice as it is when I'm changing it, because sometimes it doesn't. Sometimes it can go off the rails pretty quickly. If you do want to look more into auto layouts and what constraints are, there are you can do some reading on that. In the storyboard here, there are buttons that are available which can allow you to set that up. Yeah, and as soon as you see it in that, with where you have kind of these brackets, that's where you can start affecting change and setting up the constraints and such. But I'm not going to get into that today because it's a pain in the butt. All right, and then layout, you can see that I can define just kind of the different layout margins and spacing that's available. And events, I have access to all the events here, but I programmatically wired up a touch event in code. I didn't do it here. Hello.
Hi.
When you're defining your properties for your views, either they're going to be a get set property, or you may have controls that require you to set them through a method of some sort. So the button's a good example of, there's no straightforward way to set a title through a property, because on a button you actually have to define the value for that title plus the state that it's in for that value to apply. Because a button can have multiple states. It can be in normal state, it can be in selected state, highlighted, focus. So you're not just setting the value of that title or the title color overall, it's going to be in what state does that apply. Normal state is generally the default state, and then selected state is when you actually press down. But then when you release the click, it goes back to normal state. So that's kind of that. And most of the other properties are pretty straightforward as far as setting the values, but there are nuances that you have to be aware of, and it's good to look up the documentation to see this particular control. If I can't find a property that I want to work with, or if there's a different way of setting it, how do I work with it? It's good to look up that documentation just to see why that's different. Okay. Are there any questions about the storyboard specifically that you have right now? I know I'm kind of just whizzing through it, but I just want you guys to get into the workshop.
If you were to port, you want to port this up to Android, it's a whole entire new story, yeah?
You have to create the Android layout is a separate layout completely, right? So if you want to create this in Android using a native layout, then you have to create an Xamarin Android project and create the layout using the XML layout that we talked about in the last workshop. The only way to share the layouts between the two of designing at once is using Xamarin Forms. So if you use Xamarin Forms, and then that's a different workshop we'll get into, and how to design layouts in Xamarin Forms and what the key objects are there. But for iOS specifically, when you're talking about specific native views, then you're using the storyboard or the zip or adding the C# programmatically to the hierarchy there, right? The view hierarchy.
And then I guess business logic, you can share it, yeah? I mean,
business logic you can share. Yeah, I can create a portable class library and just put all my business logic in there, and all the ViewController does is affect change within the view, and then just call methods on the view model. or like whatever business object I have in my portable class library, right? So I can really just use my view controller to be an intermediary of that. That's which is what it should be. That's what the view controller definitely is for its main purpose is.
Is there any performance difference between, let's say, Xamarin Forms and this specific iOS?
I would say it depends on how you're designing your views. If you're designing your views in Xamarin Forms and your view is like has so many nested views within it, and it's going more than 3 levels deep, you could run into performance implications. But if it's a very clean and simple view, like something like this, it's just going to compile down and render it using the native controls anyway, and so it should be very comparable. But the problem comes in when your view is too complex and you're using XAML to create all this nested hierarchy, which it may not make sense to do within Xamarin Forms. It may make sense to do it native. Although Xamarin Forms is getting better with every release, they have, the things that they've done in the last 6 months have made it more usable in enterprise than it's ever been. Right? Prior to that, there was a lot of obstacles that people had to overcome. And now with like native control embedding, it's getting better. Their performance with their compiled XAML is better. It's definitely improved. But we'll do a workshop on Xamarin Forms soon. Okay. So then, C#, and I have to get rid of all these transitions. So essentially, you could declare a class level field for each UI control if you wanted to work with it throughout the code behind, like all the code does. Essentially, what you'd have to do in order to programmatically add a view to the code behind is define kind of the area that it's going to occupy. So you create this rectangle CG rect object, passing in the XY coordinates and then the width and height. And then when you initialize an instance of your control, you pass that rect object in, and then set your properties and then add it to the view. So in this case, I've defined that I'm going to have this rectangle that's going to start off at the X is 10 in, so a left margin of 10 in, and then a top margin of like 40 down. And the only reason that I did the top margin a little bit more was to keep it away from that title bar in iOS. And then a width of 200 and a height of 60, essentially. So then I created this text field and I just gave it a placeholder just so that people could see that there is a text field on the form. I could have affected more change on other properties, but this is just a quick example. And then the view is the view of the view controller that this resides in. So in this instance, we are in a view controller, and the main view of the view controller, I'm just adding this UI text field as a child view to that. Confused? Are we good? Okay. All right. So essentially, it's that easy to add a view in the code behind, but if you have views that are going to be they're going to have a lot of controls on it, and you can see that this can be problematic. You'll start having, you don't want your code behind to be too heavy. It's really not the best way to add fields to a view. But there's always a reason to do something like this, so it's good to know. I'm going to talk a little bit about broadcast notifications just because in the workshop, I've added a step to do something like this. Simply because this is going to be a common scenario you're going to run into, especially if you have you have text fields on a form, users are going to enter it. This is a good case scenario where you're going to use this broadcast notification to kind of change your view or to. But anyway, okay. So broadcast notifications. So this essentially enables you to listen for and post broadcast messages. You can actually have create a control that also posts messages that people can subscribe to in this way. So NS Notification Center is that notification hub. And default center property off that object is kind of where everything's going to be accessed from. So in this case, if I'm registering for notification, I have to use the add observer method off of default center. And in this case, I'm saying, well, if the keyboard is showing, then I want it to take an action. So I'm going to register a notification action of keyboard up notification. So this is my own custom kind of action that I want it to perform every time the keyboard, the soft keyboard, is actually shown on the screen. And then when it's not showing, when it decides to hide itself, then I want to get a notification about that. So I'm going to handle that in this action that I've created called keyboard down notification. So it's a very common example of when you will probably use something like this. But it is more powerful, and it is really worth looking into and seeing how you can use it more within your applications. And in this workshop, you will be using it, and you'll see why that comes into play. But it is pretty cool. I didn't want to get too far deep into it because I feel like it's really off topic of this workshop, but I added it into the lab, so I was like, well, I'm going to have to give it a shout out in the slides. Because I think the last time I did that, people didn't like it when I didn't mention it. So when you see it, that's what it is. That's why you'll be using it. But its use can extend and give you great control in your applications. It's very good to know. So now you'll get to do the workshop. Essentially, you'll have to clone my Xamarin Workshops repo and then follow the steps in the workshop PDF that's in that repo. And you have maybe 45 minutes to do it, or a little bit longer. We're here till 8 o'clock if you need to be. And if you have any questions while you're working on it, raise your hand. There is like an additional resources section with valid links to all of the stuff that we covered today, which will help you. This whole slide deck is also available in the Git repo as a PDF, so you should be able to refer to it when you're working on the workshop.